So today we want to solve rational equations, and once again we can remember what we did with fractions to help us out with this. So let's review how we would solve an equation that just has some basic fractions, like 1/2 plus 1/3 equals x over 12. Well, the first thing I want to do here is find my least common denominator for all three of my fractions. So I just listed the multiples of 2, 3, and 12, and I want to look for the smallest one that's common to all. And that's going to be 12. So 12 is going to be my least common denominator. So let me multiply each fraction now by 12. There we go. So I've multiplied each term by 12, and I can simplify this a little bit now. So I'd have 12 over 2 plus 12 over 3 equals just x. Because these two 12s are going to cancel out, right? They make a 1. Okay, so 12 over 2 is 6. And 12 over 3 is 4, and 6 plus 4 is 10. So x is 10. Now let's use those same steps to solve rational equations. Now, when we added, subtracted, multiplied, and divided with rational expressions, we looked for excluded values, and we want to do that here too. Remember, our denominator cannot equal 0. Any value that makes that happen is excluded. So that means that 5 is an excluded value from this equation. It cannot be the solution. So now let's talk about what our least common denominator would be for this expression. So before I looked at my denominators and their factors, so here's my two denominators, and if I list their factors, I have x minus 5 and I have 2. And I don't need to write x minus 5 again because neither of these terms has more than one x minus 5 in its denominators. So this is my least common denominator. So next I'm going to multiply each term by the least common denominator. Doing this doesn't change the value of my equation because I'm doing it to both sides. So now let me simplify. I have an x minus 5 and an x minus 5 on the left. And on the right I have a 2x minus 5 and a 2x minus 5. So this is going to leave me, let's go to the next page where there's a little more room, with 3x plus 7 times 2 equals 5x plus 17. And this is a nice friendly little equation like we did in Algebra 1. So let's solve it just like we did then. We'll distribute our 2. We'll subtract 5x from both sides. We'll subtract 14 from both sides. And then we arrive at our solution of x equals 3. Now we just need to determine whether this solution is extraneous. Well, our excluded value was x equals 5. Since 3 is not excluded, then x equals 3 is our true solution. How about you try it now? So pause the video, follow the steps, and when you want to check your work, hit play. So here's what you get after you multiply each term by that least common denominator. So good so far? All right, the next step is to cancel out factors that are common to both the numerator and the denominator. There we go. Now we have a much simpler equation. We can use a little distribution to solve this. And now we have a quadratic equation, which we know how to solve. We want to set it equal to 0, so I'm going to subtract 10 from both sides. Fantastic. We have two solutions here, but are they real? Let's consider our excluded values. So let me go back to the very beginning. Remember, at the beginning, our denominators were x minus 7 and 2. Neither of those denominators are allowed to equal 0. 2 will never equal 0, but x minus 7 equals 0 when x equals 7. So x is excluded. That tells us that we only have one true solution here. X equals 7 is therefore extraneous, and x equals -4 is going to be our real solution. So your steps are to find the least common denominator, multiply each term by that, and then simplify and solve. Try it again on the next example. So this is where we end up after multiplying both sides by the least common denominator. And we have some terms that we can cancel out, which gives us a much simpler equation. Again, we're going to use a little bit of distribution. And we end up with a quadratic equation. We'd like to set this quadratic equation equal to 0. And I did that by subtracting 8x and 48 from each side. Factoring out this equation gives me two solutions, but are they both valid? Let's check. Go back to the denominators we had at the beginning. Remember we had x plus 3 and x plus 6. That means our excluded values would be -3 and -6. Therefore, neither of these solutions are excluded, which means they must be real. So our solutions are x equals 9 and x equals -5.